Okay, students, so this is section 6.1, Angles of Polygon. And just recall that a polygon needs to be a closed figure. So things like this are not polygons, those cannot be polygons. So a diagonal of a polygon is a segment that connects any two non-consecutive vertexes. So if we have a square, then the diagonals would be these ones. But if we have something like a pentagon, then it has more diagonals. So this one, this one, this one, and that one. So the table of polygons, this is below, we have the triangle, the quadrilateral, the pentagon, and the hexagon. And then after that, we just call it an entagon. And as follows, triangle has 3 sides, quadrilateral has 4 sides, pentagon has 5 sides, hexagon has 6 sides. And if we kind of break up things into triangles, so if we have a quadrilateral, that would be like a square or a rectangle. If we break it up into 2 equal pieces, then it would be 2 triangles. So the degree of it is just 2 times 180. A pentagon could be split up into 3 triangles. So that would be just 3 times 180. And then finally, the formula that you need to memorize. So for any polygon, the formula is going to be n minus 2 times 180. You don't really need to know that it's also the number of triangles is n minus 2, but it could be useful maybe for a couple proofs if you need to use it. All right, so next is just the polygon angle interior sum. So the interior angles of a convex polygon. So you might want to remember that convex means that you can't have something like this. So that would not be allowed for this formula here. But a convex polygon adds up to n minus 2 times 180 degrees. So for example number 1, it says, find the sum of the measures of the interior angles of a heptagon, and that is 7. So that has 7 sides. If that has 7 sides, that just means n is equal to 7. So if we plug it in, 7 minus 2 times 180. So that would give us 5 times 180. And I'm going to take my calculator, just plug that in really quickly. And I'm going to get 900 degrees. So find the sum of the measures of the interior angles, so of all the angles. If I just wanted one of the angles, and if it was a regular heptagon, then I would just divide this by 7. All right. B, find the measures of the interior angles of a quadrilateral ABC, the one that is given. So if it's a quadrilateral, if we look up here, it has to equal 360, or you could do it, the sides are 4, so you could plug it into this formula again, and then you would get 360. So if it has to add up to 360, we're going to go 3x plus x plus each one of these are 90, so plus 90 plus 90, and then set it equal to 360. We'll subtract 90 twice, and then we'll go ahead and add 3x plus x. So that gives us 4x, and then that equals 180. So if we do 180 divided by 4, we get 45. So x is 45, but that's not the measure, so you still have to find the measures. So 3 times 45 degrees. And then this one would just be 45 degrees. So 3 times 45 degrees is 135. So these would be our two answers here. Okay, example number 2, it says the measures of an interior angle of a regular polygon, okay, so it's saying regular now, is 135. Find the number of sides of, find the number of sides. Okay, so we know that each angle is 135 degrees. So to find all the angles, it would just be the number of sides times 135. Oops, my marker I think is dead. Oh, there it is. Okay, so that's how to find the measures of all the angles, but then I also have our special formula again. So I could also set it equal to that. So n times 135 equals n minus 2 times 180. And then what we could do, we could factor that 180 in. This would just be 135n equals 180n minus 360. Subtract both sides by 180n. And then subtract those numbers. And we get negative 45. Divide this by negative 45. So n, I believe, is going to be 4. Oops, I think 8. Yep, 8. So that would be n sides. So this type of problem only works when it says it's a regular polygon, because I'm able to do this extra little formula. After that, I'm just going to set it to the formula that works for every single type of polygon, whether they're regular or not regular. And then I solve for n to find the number of sides. All right, our last theorem is just the sum of the exterior angle measures of a convex polygon is 360 degrees. So no matter how many sides it has, the exterior angles, so don't confuse that with the interior ones that we had up here. This was interior, and the one down here is exterior. So the sum of those is 360. So if we add those all up, we get 2x minus 5 plus 3x plus 10 plus 5x plus 2x less 6x minus 5 equals 360. We could add the like terms together. So that gives us 10, 16. And then we could add the rest of them together. Oops, I forgot this one. So that's 18. So that would actually cancel out the minus 5, positive 10, and another minus 5. set it equal to 360 divide by 360. And then if we plug that into our calculator, we should get 20. Okay, oops, that shouldn't have a degree there. So that would be our answer. All right, so if you want to try this one, and then I will post the answers to this on Schoology when it's all filled out. All right, guys, have a good day. Have a good weekend.